Everybody, Dr. A here, and in this video we're going to be exploring another example of allowable stress. So let's take a look at the given information. Here we're being told that if the bearing strength of the connection is sigma fail equals 50 KSI, that's kips per square inch, compute the factor of safety against bearing failure for the bolted connection. So here we have this three-dimensional figure of a piece of a plate that has 3 bolt holes in it. Now that plate is 1 inch thick, and we see that we have these 3 bolt holes that are bored in it. There's 1, there's 2, and there's 3. Now this connection is being subjected to a 2.5 kip force at its connection, and the bolt diameter is 1/2 inch. So let's go ahead and get started. So under solution, the first thing we're going to recognize is we need to use our factor of safety relationship, which will be sigma fail over sigma allow. Now we know that because we were asking for a factor of safety calculation, so we know this has to do with factor of safety. We also need to use the sigma nomenclature here because bearing stress is a type of normal stress. So we use tau for shear stress and sigma for normal stress, okay? Now, the next piece of information or relationship we need to remember is that sigma allow is going to be a force divided by some area. Now, in particular, this is going to be a bearing force over a bearing area because we're dealing with bearing stress. Okay, now the question becomes, what is the bearing area here? Well, notice that this figure shows a pretty simple connection with 3 holes bored into it. And so those 3 holes are going to be subjected to bearing stress from the 2.5 kips. So what's the bearing area? Well, it's going to be the projected area, which is a plane. It's a rectangular shape, projected area on all 3 of these bolt holes, okay? So we actually have 3 areas here that are going to be subjected to bearing from this 2.5 kips being spread out over them, okay? So I'm gonna say the bearing area is gonna be equal to the thickness of the plate times the diameter of the bolt, and there are 3 of them, okay? So we're gonna say multiply by 3 because of the 3 bolt holes there, all right? Now what we can do is put all of this together, all right? And we can solve for factor of safety. So I'm gonna say Fs equals sigma fail divided by FB over AB. I'm gonna do a little bit of rearranging and say sigma fail times bearing area over the bearing force. And then again, the bearing area is this relationship right here. So we're going to say sigma fail times thickness of the plate times the diameter of the bolt times 3, all divided by that bearing force. Now, do we have all of these values? Yes, absolutely. So we're going to say Fs equals sigma fail was 50 KSI. That's 50 kips per square inch from our given information. The thickness of the plate was 1 inch. The diameter of the bolt is 1/2 inch. And we have 3 of them. And then we divide by 2.5 kips. Okay, now if you track these units, you'll see that the units kind of combine and cancel out. You have kips canceling with kips, and then you have inches squared here, inches times inches canceling with inches squared. And so you finally get a value of what? Let's punch this in together. We have 50 times 0.5 times 1, of course, times 3 divided by 2.5. So we get a huge factor of safety of 30. So in this very simple example, is this bolted connection going to be in danger of failing in bearing? No way, okay, no way. So we're going to say since the factor of safety is much, much bigger than 1.0 in bearing, this connection is in no danger of failing in bearing. Okay. Now, you still, in a larger problem, would have to check for shear through the bolts, right? Because that's a different, what we call limit state that could control the connection design. But in terms of bolt bearing, you are in no danger of failing here because you have such a high factor of safety. Now, I want to kind of end this video with just a little disclaimer. This particular problem is really just for illustrative purposes in helping explain the concept of factor of safety and allowable stress. This is not really necessarily a practical structural engineering bolt bearing connection process. So this is more meant for the sake of mechanics of materials and introducing the concept of a factor of safety and the concept of allowable stress. This is not meant to be a machine design or a structural design process that you would get in a structural steel design course or a machine design course for either civil or mechanical engineering. This is just meant to be a brief intro to factor of safety and bolt bearing using allowable stress design for the sake of an introductory to mechanics of materials. Okay, so if you found this video helpful, please hit like and subscribe and be on the lookout for other content like this. Thanks for watching.